Hello everyone, my name is James Ryan and welcome to my first vlog, water probe prototyping. Just a quick warning, this is a vlog, not an electronics tutorial, so while you will learn how to make a water probe while watching this video, there will also be extra vlog stuff unrelated to electronics. So if you're looking to learn how to make a water probe without all that extra stuff, then I recommend checking my channel to see if I've made a proper water probe tutorial, or otherwise checking elsewhere on the internet. With that out of the way, here's the video. My name is James Ryan, and today we're going to do some electronics. So, the other day I went to JCar and I bought some electronics, mainly for the purposes of making a robot car thing, bucket, that can do line following. But while I was at it, I thought, well, my toilet at home got a bit of an issue. Basically the system stopped working, and I thought, I wonder if I could just and so because of that we have to control the tap and stuff. We have to put it on and then wait 5 minutes to turn it off and all that. But it got me thinking, could I build a water probe? That is, could I build an electronic circuit that could detect whether or not water has reached a certain height? Say, for example, in the toilet cistern, and then use that information to say, turn on and off the valve. Or turn off the valve once the water reaches a certain height automatically, or whatever. You know? So, yeah. Electronics that I got from JCar, and I'm going to try and build a water probe. I'm just going to be testing with a cup. I'm not going to use the toilet or anything. That would be silly. Maybe in the future. So, I'll show a schematic on screen that I plan to use. But the basic idea is that I'll show the diagram on screen for a bit. Is that water conducts electricity. So this design relies on the fact that most of the water you encounter in everyday life has some impurities. So it will conduct some electrical current. If you have two probes, and they are both in contact with some water, the same body of water, then some current will flow from one through the other and produce a little bit of current. Technically, pure water doesn't conduct electricity, but most of the water you find lying around, especially comes from a tap or in the toilet or whatever, will. As a last minute addition, I've decided for the moment we'll also be using another resistor in conjunction with an LED light, just so we have a simple on-off light to let us know whether or not we're in contact with water. But you can also obviously replace this with much larger loads if you have much larger battery. But if you want, you can also do other things, say use a pull-up or pull-down resistor in conjunction, so you can use it as an output to a microcontroller or some other circuit, or you can run a much larger load if you have a much bigger power source attached to, say, a separate circuit, so you can have a separate power source for the probe circuit and the transistor circuit. So that way the probe can work on a low power source and power some very high power stuff, say 12 volts or something. You guys know I'm following the basic layout from here from an Instructable. I'll put the Instructable in the description, but I'll be making my own modifications. So my circuit will probably be a little bit different from this one. Now is a good time for me to briefly show and explain the schematic. Power is supplied to the probes, and when the probes detect water or are otherwise electrically connected, they turn on the transistor and allow current to flow through the load, turning on the light. Now, throughout this video, you'll hear me mention a pull-down resistor, but instead, in this actual diagram, I have a base resistor. This is because I was following a website, and it turns out that pull-down resistor is bad. It only makes the circuit less sensitive to water. Instead, I have a base resistor which limits the current going into the base of the transistor, stopping it from blowing up. So this is the actual circuit that I'm using, and not the one I was actually building during day one of this project. So whenever I mention a pull-down resistor, just replace that in your mind with base resistor and you'll be a-okay. I also want to show off this useful variation of the circuit, which is very similar to the last one, except this is the version that you would use if you wanted to connect the probe to a microcontroller or other integrated circuit as an input to it. And the only difference is, instead of the load, we've replaced that with a 10 kilo ohm resistor followed by an output. And the way it works is, instead of the transistor letting current flow through the load, the transistor now lets current flow through the resistor, so the voltage will drop across it and form a low at the output when the water is detected, and it will form a high at the output when water is not detected. So it is an inversion. This is active low, so this will go low when water is detected. If you want to know the materials, how to make this yourself, everything you should need to know should be in the description if I do my job right. Let's take a look at the materials you'll need. First of all, you'll need some resistors. I've got quite a few resistors here, but we'll have to choose the right one for the job. For this project, I've decided we're going to use some 10k resistors for the probe, and I'm going to use a 100 ohm resistor for use in conjunction with the LED. So you'll need the LEDs themselves. You just need one for the moment for this project, just so you can have a simple on-off light. Remember that on an LED, the slightly longer leg, shown here, is the anode and connects to the positive terminal. The other leg, the slightly shorter one, is the cathode and should be connected to ground. More specifically, voltage should drop from the anode to the cathode in order to power the LED. Current will not flow in the other direction. Current will not flow if the voltage drops in the other direction, and the light will not turn on. You also need a general purpose NPN transistor. The most common ones for this use are the BC548 and 547. The only difference between those two is their technical specs in the voltage. One of them is rated 30 volts and one of them 50 volts, and none of that really matters that much for the types of voltages we're operating at, which is going to be between 3 and 12. So yeah, get either one, and make sure that when you put the BCE in, note that when the flat side is to the left, the top pin is going to be the collector, the middle pin is going to be the base, and the bottom pin is going to be the emitter. The other thing about transistors like this is that they're very fragile, so don't go bending their legs around too much. Try and be as careful with them as possible, or they will break, and then you'll have to get another one. So another good tip is to buy these in bulk. Get at least 5, 10 if you can afford it. I mean, it's very cheap there. It's like $2.70 for 10 of them where I live, so yeah. Go down to your local hobby store, and that's a good place to get most of this electronics. Lastly, you're going to need some type of wire or jumper cables. I have a couple different types of jumper cables here, so I'm all good in that regard. But you yourself might need to either buy some jumper cables or buy some wire and cut it yourself with a wire stripper. Up to you. Need some sort of breadboard to put everything together on, and some batteries, a battery holder of some sort. I've got a battery holder right here, but my breadboard also has a built-in battery holder. Don't know how old these batteries are, they might not work, I might have to replace them. But yeah, either that or you'll need some type of proto board or perf board or something to put the things in and then solder them with. So breadboard or some type of prototyping board. It will be pretty good. You can even make a PCB if you want a more permanent solution. Although, if you're going to go that route, I suggest simply buying a kit. I know at my local J-Car there is a water sensing kit that you can get for about $9 to $10. I think it was maybe $9.95, and you know, that has everything you need in it to make a simple water probe sensor, including the light and an output, and it has a PCB already in it. So if you're going to go that route, just buy the kit, you know, very simple. But you will of course need to solder that yourself, because you know it is a DIY store. First thing I want to do is a quick test to see if these batteries work. So I've got my positive hooked up to this red wire, and then that goes into the resistor, which goes to the LED, which then hooks into ground. So when I connect up ground, you'll see it turns on very slightly, but not strong enough for our purposes. So we need to lower the resistance, or I'll try again using new batteries. So let's get that done. Luckily, I already also have a battery case that I bought from J-Car a long time ago, so I'm going to fill this with 4 new batteries, and I'm going to try and use this on the rails instead. It all filled up with batteries and ready to go. So what we're going to do is let's just take these out of here. Don't need those there. What I'm going to do is I'm going to stick the batteries here. Oh god, the ground on this thing doesn't... I'm going to need some wire strippers. Wire strippers right here. So now I fixed it, the idea is I'm going to put the ground on the ground rail, and I'm going to put positive on the positive rail. Oh, I better fix that up. Just needed to twist the wire inside around a bit, the threads, so that they could be properly inserted. Got the 5 volts running through the jumper cable to the resistor. Then we connect the resistor up to the LED. And then when we connect that to ground, hopefully it lights up, and there we go, nice and bright. It looks even brighter on the camera. So that's how you know you got some good working batteries. So we'll just disconnect that for the moment. And what we want to do now is, instead of directly powering that, we want to power that via a transistor circuit. So let's get that sorted out. To be clear, that's the 100 ohm resistor in line with the LED, not the 10,000 ohm resistor. We're using these jumper cables, which I've connected to other jumper cables, as my probes, and I've got one connected to high voltage. When I say high voltage, I just mean positive voltage. And whoa, what's that? That shouldn't be happening. Oh god. I've fixed the problem. One of them is connected to positive voltage, and the other one is not connected to anything right at the moment. It's just standing there, but soon we're going to connect that to ground via a 10 ohm resist, a 10,000 ohm resistor, 10 kilo ohms. So we'll do that. So now time for the transistor, and the way we're going to do this is, instead of connecting the LED directly to ground, we're going to connect the cathode of the LED to the collector of the transistor. And you just need to spread the transistor's legs a little out before you put in the breadboard. But after that, it should all work just fine, like so. And so then after that, so what we're going to do is we're going to connect the emitter directly to ground, because the load is going to be before the collector in the circuit, and the base, which is going to be the control of whether or not the light turns on, is going to be connected to the output of the 2 probes after going through a pull down resistor, which is going to be the 10 kilo ohm one, which is right there. So if I just move this resistor leg a little over here, we can stick another jumper cable in, connecting the output for the probes to the base, and then last but not least, we'll connect the brown one, ground, to the emitter of the transistor. So hopefully now, if these 2 wires here touch each other or come into contact with water, it should light up the LED. So let's try that. I'm going to put this one in here. I'm going to stick the other one next to it, and hopefully that lights up the LED, as long as we have the battery connected. So let's connect up the battery. All good? Alright. Alright, got that fixed up. Here goes. Didn't work. Maybe I blew something. Hello everyone, so it's been an entire day since the last recording I had. It's been a whole day since I last recorded, and a lot of stuff has happened. Basically what happened is I ran out of video space on my camera. I stopped recording because I ran out of space on my camera. And then I decided to go to sleep, and now it's been a whole day, and I've been doing other stuff, and it's also been a nightmare just to get the videos uploaded to Google Photos and off the phone. And I've been trying to get the photos uploaded to the computer so I can free up the space on the phone and all sorts of stuff. And I mean, I did try around with the circuit a bit, and I got it working, but it wasn't quite the original circuit design I planned. I just spent like an hour just researching transistors, just because I was confused. It doesn't actually help me that much with this project, but it is interesting what I learned, and I think I'll talk about it in the future. And basically, what happened last night is that after I stopped recording, I continued testing it and I got it working, but I did have to make some arrangements to the circuit because it turns out I was wrong. I've decided I didn't know whether I was going to make this one a vlog or a one-off video, but I decided to make it a vlog because I have made some mistakes, and the initial designs I came up with, they turned out to be wrong. That website, not entirely wrong, but the thing about that website is basically the main thing I was wrong about was the pull-down transistor. This here is no longer a pull-down transistor. It is now connected directly to the base. So instead of connecting this transistor to ground, you connect it to the base of the transistor. I don't want to mince my words. You connect the resistor from the probes. So you have, for the probes, high voltage on one end. The other end connects via a resistor to the base. None of the probes touch ground at all, and the reason for that the whole point of the pull down resistor is it's sort of a safety thing usually in electronics, so that you don't put too much current into the device. But in this case it's counterproductive, because what it's doing, all the pull down transistor was doing is it's actually weakening the signal. It was actually making it weaker. Because if you don't have a resistor there, then it's the equivalent of no resistance. I mean, it's the equivalent of infinite resistance, basically. Or, you know, the resistance of the air, which is very, very, very large. We don't need a pull-down resistor. We just use the air, and the air has very, very large resistance. Infinite for our purposes, but not really infinite. You know, it can break down lightning and stuff. So there's no point to it. All it was doing is weakening the signal, and I guess the point of that is you can use what you're supposed to do. You might want to put in a resistor if your device is too sensitive. Like in the original designs, you have a potentiometer there, so you have an adjustable. You can adjust how sensitive. You can adjust how sensitive it is to water, and you know you might want to do that in the case of if you have, you know, a device that's way too sensitive to moisture, or say the moisture content in the air or something, if you're in a really humid area. But it's not really a problem over here, it's just silly. For my case, you don't really need that. I hope I'm getting good lighting on me. I'll stay here, I'll stop moving around. So that's that, and the other reason we need a resistor, we can't just connect it directly from 5 volts to the transistor like I was doing before, because that's basically what was happening, is that when the probes touched it, short-circuited through the probes directly into the transistor, and it wasn't working, my light wasn't turning on. I'm very lucky I didn't smoke and blow up the transistor. It seems to be clever enough to notice that I was driving too much current through it and save itself somehow, so that's very good that they can do that. Either that or I just got lucky. But, you know, we just put a resistor. I'll show you the diagram, the new diagram. I'll just show the correct diagram, and I'll have a little message on the screen saying that I don't know what I'm talking about. Ignore what I'm talking about. That being said, I managed to get these probes to work together. It turns out if you just push their jumper cables together a bit more, they will slot into each other and stay like that. So that works good. I'll show you an example of the circuit working via the transistor. So these batteries, these are not directly connected to the load. I do have to correct, based on what I've learnt, something I said before. So I'll make another video based on that, of what you can and can't do with this type of circuit, especially with the probes like this. But I do think that I can get this hooked up to an Arduino, or perhaps to a motor controller or something, just as easily as the load. But I think it might require a bit of cleverness. I think you can probably just plug it directly into an Arduino or something, but you know, I'd have to look at the schematics. As I was doing before, if we just put the battery in the right place, so we put the positive and negative on the rails, you can, oh man, that doesn't look very good. You can see that when these wires touch, the light glows. And these wires are not directly connected to the battery in series with the LED. They are going through a transistor, so these probes, whether or not they touch, is actually controlling a transistor, which is a common, it doesn't matter. Look, the transistor is like a switch at the bottom, and it's technically called a common emitter configuration, and the load in this case is the LED and the resistor that prevents too much current running through the LED. So that is what causes this circuit to light up when in contact with water. So let's just get a cup and we'll see if it works. It does, I've tested it. I've brought a nice little cup of water here, and while you normally don't want your electronics projects to get too close, or electronics in general, to get too close to water, in this case it's a necessary part of how the project actually works. So the idea is, if I just manage to be able to show both at the same time, the electricity and the cup, and the cup, if I put one probe in the water, and I put another probe in the water, it should light up. Sorry about that, I've had to switch to my iPad because my phone's being very temperamental about how much space it can have in it. Even though I deleted 1.8 gigabytes, it's just not letting me. So I guess the podcasts I downloaded earlier in the day have finally decided to take over my phone. In any case, we'll get this video over with soon. And then today is Thursday night, so hopefully I get this up by Friday. That being said, today is Thursday the 9th, so if this is up by Friday the 10th February, I've done good. Anyway, so here is, you can see when I put the water in, when I put both probes in the water, it works. It switches on the transistor and allows the LED to turn on. For my next couple of experiments, hopefully we'll see if we can use something like this to turn on like a motor. And if we can, and if the motor can turn the toilet valve, then maybe, just maybe, I'll use that and we won't need a new cistern. But we shall see. Thanks for watching. It's going to be one heck of a thing to edit. If it turns out good, if this turns out good, I'm going to do more vlogs of this style, maybe even with programming as well, but I'm going to try and make sure I have a specific goal in mind. It doesn't necessarily have to be an entire program or project like this. It seems like one, it just needs to be a good topic and a good goal. This here, this water probe, it seems like one project, but really it's actually a part of, you know, a possible bigger project. I don't think I'll end up doing the water probe thing. The toilet thing. We'll see. Just testing. But I think it's good. And I'm kind of like, now that I'm able to show a bit more mistakes on camera, because of the vlog thing. So, yeah. Hopefully we can bring the excitement of this, if it is exciting, to some programming. But I'll have to do it right this time, not the wrong way. Okay? No more series. That was the issue, is doing it in a series makes it sort of, you just do so much programming. When you get into it, and you record so much, and then you lose people, or you show off too much. And, you know, I want it to be entertaining. Obviously, it's not as big of a problem with electronics, because I'm not as, I won't do electronics as fast as I program. But, you know, recording slows you down, and all that jazz, and, you know, I can talk about it later. We'll talk about it in another vlog where it's just for talking. But that's enough for today. Talk to you more later. Other vlogs, other videos. That's the point of the channel. See you later. My arm is getting tired holding up this iPad. Whoa. And the last thing I want to talk about is that I will make this a vlog. I was thinking, you know, should I make this a vlog or should I make this its own video? And I was originally going for that, and that's why, you know, at the beginning I'm going like, oh, this is this, and here's what you'll need, and make sure you get the transistor right and stuff. And the reason I was doing that was because I was going to make this like a, sort of a mix of between a tutorial video and a come prototype with me thing. But you can only make so many mistakes before that starts to get irritating if you're trying to watch it as a tutorial. So, and you're not just here to learn along with someone else. So, yeah, hopefully, so yeah, that's why I'm making this a vlog. Hopefully I can do that with the other things, like when I'm programming. Hopefully it's not too boring to watch that type. That's one of the reasons why I stopped the old series. I'm still going to upload the rest of it, but that's kind of the reason why I don't really want to do that anymore. Is that I realize it's kind of boring. It gets kind of long-winded to watch someone program and then just go through all the nooks and crannies with them. It's a little bit more. It tends to be that the less you show between the programming, between milestones, the more interesting. So if I just show the major milestones, that, I'm not saying it can't be interesting, but in general, what I wanted for the series, the original ones with the programming ones, I can start talking about other things other than this project now that this is properly a vlog. But the whole reason is that originally I wanted to just show between milestones, and then I got sidetracked recording, you know, and this is how I did it and stuff, and it turned into sort of weird mix between come do this with me versus reporting versus all this troubleshooting, and it just wasn't going to work out. So I think what I've done here, where I start off sort of instructionally and then as things sort of break down I become more casual, I think that's actually kind of a good, entertaining almost solution. Obviously I'm going to evolve over time. I've changed since I started doing those series. That's why I cut those series. I mean, they're still going to go. I'm going to upload the remaining raw footage, but it's not what I want for the rest. So just let me know if you like this style of video, if you would prefer me to just do it myself first, and then once I figure out all the problems, then to upload that. Let me know which one you prefer. If no one watches this and I don't get any comments, I can't really make it better, can I? In any case, let's finish off the rest of the circuit. I also spent like about an hour because I was a bit confused about transistors, and I learnt quite a bit. Maybe a bit of a waste of time, but hopefully not. Hopefully I can get a video out of it. I won't include that in this video's creation log, but maybe if I'll use it as like research or brainstorming in another one, because, you know, even though it was just personal curiosity, I think it does count as research. So yeah, basically this works, and another thing that the reason I want to make this a vlog is the editing becomes a bit easier, the editing, if you just put everything in, because, you know, I can try my best to edit this to look like a proper tutorial or look like I know what I'm doing. It's just not going to work out. So yeah, that being said, it's going to be one heck of a thing to edit. Making videos takes time and effort. Please support my efforts by liking this video and leaving a comment. Your feedback is appreciated and lets me know people are watching.